What is gravity? Gravity is a serious area in the study of physics. It would be absurd if we don't dedicate a lecture to the study of gravity. Before we describe gravity, let me pose a question. And the question is this. For those who are born, let's say about 5 or 6 decades ago, and of course till present, can you honestly tell me that you have not at any time coveted floating? Or have you not even thought of the mystery of levitations? And how many of you have even dreamt floating before? I believe so many people must have. Well, this is sort of an indulgence when we were young, watching TV, seeing astronauts flying up and down. One, has actually attracted our attention to the extent that we also want to float. Be that as it may, and taking that as the world thinking of a young folks. Now, can we say, what is the truth? The truth is that without gravity in this world, the dream of floating, the dream of being able to levitate, it will not even cross anybody's mind. Okay? So, it then means we will not even experience gravity. You can only experience those things you know about. By the way, we will not even know we are being pulled by the force of gravity. Now, let's look at the subject and ask ourselves this question straight. What is gravity itself? Gravity is the force that attracts body towards the center of the earth or towards any other body having mass. So it can also be said to be an invisible force that pulls objects towards each other. I'm quite sure you have not be able to touch gravity before. This is not by accident, because many of the other forces are the forces you can see. They have contact points. Then it is very natural for you to always think that even gravity does not exist, but it does. So gravity, again, in a simple language, is the force that acts on us when we jump up and we find ourselves quickly coming back down. It's also responsible for all objects that we ever throw up and come back down immediately. Well, if it is not near exaggeration at all to claim that the earth will be inhabitable without gravity, humans as well as objects will be falling apart and of course colliding. It is better imagined than to be true. So the essence of gravity in our life cannot be, quantified easily. Now, how did we discover gravity? How did we get to know that gravity exists in our environment? Well, the first thing is, in nearly all tribes, culture, and civilization, there is a popular saying, and of course it exists even in the local languages of many, that whatever goes up must come down. The phrase is the most true and authentic statement on earth, and it does not matter whether you are a physicist, scientist, astronaut, or not even any of this. It is a fact living with you that you cannot dispute. It is what you can test even as you are sitting down. Throw an object up, it comes down immediately. Having said all this, let me take you through the history of gravity as it has been uncovered over the years. How did the push into investigation of gravity started? Now, we don't look elsewhere. We just need to answer this. And how do we answer this? Is by looking once again at the contribution of our usual hero of physics knowledge. The earliest studies was by a German mathematician and a very intelligent man known as Johannes Kepler. He is a graduate of Tübingen University and began research in the field of optics. He published a book that earns him a title, Founder of Modern Optics. He was the first to investigate the formation of pictures with a pinhole camera. He also expressed process of vision by refraction within the eye. He did so many things, and finally in 1605 he announced his 3 laws, and those laws were one of the laws of planetary motion as we have it today. This law I will discuss towards the end of the lecture. Now, the second person is Galileo, who, according to his story, he held 2 similar balls with equal weight and dropped the 2 from Tower of Pisa in Italy, and that those items got to the ground at the same time. This proves the fact that objects under the influence of gravity travels the same time, and that is irrespective of mass of the object. Let me say here that prior to that period, Aristotle has done an experiment in which he claimed that the mass of the object is proportional to the speed and time of getting to the destination, which is quite contrary to this. But this issue was left like that and was not popular until the big fish and the genius of physics, Isaac Newton, whose work on physics actually can every time be compared to Mona Lisa in art. Newton's contribution, you will recall, is one of the most popular contributions to physics and science in general. The three laws are as popularly propounded by him. It borders on force. However, from him, another law that ordinarily should have been fourth law of motion also came, and the law is called Newton's laws of gravity. Before I state the law, let me, for the purpose of fulfilling all protocols, repeat a story of how Newton started the investigation, to the study of gravity. The story goes like this. Newton was quietly sitting under an apple tree one day, and an apple fell on his head, which woke his consciousness to the process that led to him thinking that if apple can fall under a particular force freely, he then wondered why moon did not fall, and he concluded that there must be a force similar to the one that led to the falling of apple, which governs motion of moon, earth, and sun. From that day, the story of ignorance of free fall changes, and human now realize what is going on. Going back to the definition, gravity is the force of attraction between objects and the earth. Consequently, man and objects like cars, ships, and even animals were all stable and not falling because gravity kept us in place. If we jump, we will be returned to the ground immediately because the earth attracts us immediately. Further to this, and the gravity pull between the moon and earth also causes ocean tide, which has the advantages of preservation of our ecosystem, fishing and harvesting, pollution control, and power generation. And of course, if I have to let you know, tides is the rise and fall of sea level caused by the combined effect of gravitational forces exerted by the moon and sun, and of course the rotation of the earth. Now, let us go back to Newton's law of gravity. Newton discovered the relationship between the motion of the moon and the motion of the body falling. So Newton's law of gravitation, which he propounded as a result of that, it states that any particle of matter in the universe attracts any other with a force very directly as a product of the masses and inversely as the square of the distance between them. The formula expressed in this way is F is equals to G m1 m2 all over r square. F is the gravitational force, G is the gravitational constant, m1 m2 is the product of the mass under consideration, where r is the square of distance between the two objects. So in very simple word, it says that any two masses attract each other. Just hypothetically look at any two masses. It will attach the second mass with a force equal to the constant multiplied by the product of the two masses and divided by the square of the distance between them. Okay, so this is a very interesting and good insight which he was able to put on ground, which helped us today to be able to go to space and all that. But there is a consequence. Let's consider Albert Einstein's contribution to gravity issue, because one will have thought that the issue is solved, but no. Newton also has some understanding. So finally, let's consider Albert Einstein's contribution to this gravity issue. First, gravity is a phenomenon that has many stories, starting from Aristotle to Kepler to Newton, who eventually give a proper insight into the issue. Consequently, from all these stories, apple falling and so on, the law of gravitation by Newton, and consequent upon his submission in his book, where he said he cannot specifically say what is the agent responsible for gravity. This is a puzzle that remains with us since after Newton, and the puzzle remained like that unsolved. 300 years later, Albert Einstein now came And about this thing, as a person can be said to have been able to solve this problem through what we can just probably refer to as defined intervention, because it is not that any serious experiment was done. He came up with theory of relativity, where he said gravity is a natural consequence of a mass influence on the space. And in addition, he also said that mass can prod space plenty. It can bend it, push it, or pull it. And at the end of the day, he said gravity was just a natural outcome of mass's existence in space. So all of this gave us an insight, but for test this itself, to graphically show what it's talking about, there's an experiment of using a trampoline, you wrap it around a round object, and then in between you drop a very big mass, and then you try to drop a ball and roll it round. What you will see is the fact that it will be rolling without crashing into the big body. So I am going to show this just diagrammatically for you to understand. While I think at the stage we are, and let me also say that was theory of relativity. So at the stage we are now, you must have understood so many things about Newton's law of motion. So in conclusion, I hope you enjoyed the lecture on gravity. And of course, where we are going actually is to begin to explore space and begin to explore creation itself as understood by men. So all of these are fundamental to understanding all those issues. So I want you to look forward to my lectures, the one that will drop on rocket science, the one that will drop on space, and every other thing that has to do with astronomy. Thank you very much for listening. I want you to continue to subscribe and like my page so that I'll be able to do more and more in this respect. Thank you very much.